Hello there, algebra students. Mr. Lawrence here, and this is going to be the first of a few review videos. My honors kids said they would really like them, so I'm going to go ahead and do them. I know some of you in level 2 will watch them, and some of you won't care, and there's nothing I can do about that. So for the kids who will watch them and do their best, I'm going to make the videos. So first of all, this really was covered on the midterm, but you never can get away from slope-intercept form. Remember, it looks like y equals mx plus b. It's slope-intercept form of a linear equation. Quadratics do not have a slope. They could have a y-intercept. Usually they do, but I guess it's not 100% guaranteed. Remember that m stands for the movement or the slope, okay? And b is the y-intercept. It's where you begin graphing. Now, for something to be in slope-intercept form, it must be a linear equation, and y must be alone. Very important. Some of you will look at this green equation and think the slope is 4 over 1, and you're absolutely incorrect because y is not alone. So let's refresh our memory. Oh, by the way, if you feel like, this is just a rough overview. So if you see a gap in your learning or something you didn't master, you should be pulling out Math Excel and going on the study plans for that section. Of course, you can ask for help. You can come after school, something like that. But I'm not going to be providing like 85 worksheets on this stuff. I gave you the review, and then if you need extra practice on a specific topic, you can do that using the study guides in Math Excel. All right, so this red equation, the y is alone, and the y-intercept is 6, or the point 0.06, right? Because I'm on the y-axis. And so I plot that point. Now my slope is -2, which I like to keep as a fraction when I'm doing slope. So I could go down 2 and then write 1. And I could go down 2 and write 1. Of course, I could use the slope m equals 2 over -1, right? Where I could go up 2 and then left 1, up 2 and then left 1. And you see how all the points are collinear. They're all on the same line. Okay. So let me draw the line in here. And I got to put an arrowhead on, and I'll change them to red because I am going to do a second line on this graph, so I didn't have to make up a whole bunch of graphs. You should never do that, though, on homework or a test or anything like that. You definitely want to keep one line per graph. Okay, unless instructed to do otherwise. All right, so there's the red one. Now the green one we mentioned, y wasn't alone, so I have to get y alone. Well, they're attached by multiplication, so I'll divide. Okay, remember I have to do it in all 3 places, and so then y will equal 4/3 x minus 2. So my y-intercept is -2, and my slope is rise 1, 2, 3, 4, run 1, 2, 3. Okay, I'm going to rise 1, 2, 3, 4, run 1, 2, 3. Okay, I could always go down 1, 2, 3, 4, and then 1, 2, 3. So it's going to be right there. I better recount that so I can see it better. All right, let's see. 1, 2, 3, 4, 1, 2, 3. And if I'm doing this right, all the points will be collinear. By the way, how many points are on this line? Well, shame on you if you said 4. You're absolutely incorrect because there are an infinite number of points, right? Yeah, I'm showing 4 points. I can tell you the coordinates of 4 points just by looking at the graph, but there are points everywhere on this line, every single place. All right, let me make that line green. All right, and put an arrowhead on, and then there you go. Okay, so here's another equation. Now, I probably wouldn't do this one using slope-intercept form, but this is what this is about, so I'm going to go ahead and get y alone. So my first step would be to subtract 2x from both sides, right? And I'm going to get -5y equals 20 minus 2x. Now, I've advised you in the past to put the x term first, but you don't have to. It's not wrong to write it this way. You just have to be careful if you don't put the x term first, that you don't get the slope and the y-intercept mixed up. So let's see here. I think y is going to equal -4 plus 2/5 x. So the slope is -4, and then rise 2, run 5. All right, rise 2, run 5, and I'm not going to change the slope on that one. Okay, now one thing we should point out is that when the slope is positive, the line will go up to the right, and when the slope is negative, the line will go down to the left. All right, and I'm just going to draw an arrowhead on this because I want to move on. I don't want this video to be too long. All right, so that's slope-intercept form. Now, one thing that also was on the first semester, but it's important to know how to calculate slope. Make sure you know how to do that using this formula. Okay, I'm not going to do any sample problems with that. If you want to ask about it in class or after school, that's fine. All right, there's another type of form we know for a linear equation. That's called point-slope form. If you notice, that's very familiar to the formula I just showed you. Yeah, the only thing is they've got the y minus y sub 1 part of the equation alone. Remember that when you're here, this is your slope, and the point is going to be x sub 1, y sub 1. And notice that they change signs. Here they're minus, right? Let me highlight that. Okay. And here it's also a minus, but in the actual coordinates, they're positives. So if I want to graph this, and I must not have set this one up for graphing, sorry about that. It'll only take me a second to do that. Let me get an equation here. Let's say I have y plus 3 equals 2 times the quantity of x minus 4. All right. If I want to graph this, I'm going to first identify the point, which is not going to be a y-intercept, but it's going to be the point for -3. Notice I changed the signs. And then I'm going to identify the slope, which is going to be 2, or better yet, 2 over 1. So the slope is 4, -3, right there. And the slope is rise 2, run 1. Rise 2, run 1. Right? Okay. So let me get a line going through here. And there we go. Make your lines take up a good portion of the graph. Don't just sit and draw line segments. Make sure they have arrowheads on them. There it is. Okay? All right, another type here. Standard form of a linear equation. And that looks like ax plus by equals c, and that's when a is greater than 0. This is different than standard form for a quadratic, where we have ax squared plus bx plus c equals 0. This is ax plus by equals c. So a little bit different. You might want to make some flashcards to keep this stuff straight. Remember I taught you some shortcuts. To find the x-intercept, you're going to take c divided by a, and the y-coordinate is going to be 0. To find the y-intercept, the x-coordinate will be 0, and you'll take c and divide by b. To find the slope, you'll just do the negative of a over b. Now, you only need 2 of these 3 things to graph. So let me try this red one here. Let's see, I don't think I like the x-intercept because I don't want to divide 4 by 3. So I'm going to find the y-intercept, which is going to be 0, and then 4 divided by 2, or better yet, how about just a plain old 2, right? Oh, maybe I should do the ABC thing, right? ABC. Easy as 3, 2, 4. All right, so I'm going to plot the y-intercept at 0, 2 right there. And the slope is going to be negative of a over b. So we're going to go down 1, 2, 3 and right 1, 2. I go up 1, 2, 3 and left 1, 2. All right. So there we go. And I am going to take a second and make that one red because I'm going to graph the other line on it. Remember I mentioned earlier that the negative slope would cause the line to open downward. Sorry, my airliner is just not doing so well these days, but that's okay. We'll make it work. I don't think that's the right thing. There we go. That'll work better. Okay, so I'm going to come over here to the green one. Now, the green one is not in standard form because A is not positive. A is not greater than 0. I can still use my shortcuts, and they'll work out just fine. But I really should either multiply or divide by -1 to get it into standard form. And when I do that, I have to do that to all three terms, and so I'll end up with 6x minus 5y. That's going to equal -12. And this time I do like the x-intercept. I think the x-intercept, well, let me do the ABC thing, sorry. ABC. Easy as 6, -5, -12. All right, so the x-intercept looks like it's going to be the point -2, 0. So -2, 0. And the slope is going to be the negative of A over B, and those will cancel to 6/5. The two negatives will cancel. So I'm going to rise 6, so 1, 2, 3, 4, 5, 6, and run 5. 1, 2, 3, 4, 5. And did you notice that our slope was positive, and this line is going up to the right? So let's go down 6. 1, 2, 3, 4, 5, 6, and then left 1, 2, 3, 4, 5. Right there. All right, so let's draw our line. There we go. Oh, excuse me. All right. So that should do it. Okay, very good. All right, so that's standard form. Now, parallel and perpendicular lines. Do you remember what's true about parallel lines? Parallel lines have the same slope. So slopes are equal to each other. But perpendicular lines, their slopes are negative reciprocals. Negative reciprocals. So if M slope is 2/3, a perpendicular slope is going to be -3/2. Right? Over here, if the slope is 4/7, then the parallel slope is 4/7. Yeah. Okay. So I want you to give me the equation of a line parallel and a line perpendicular to this line, this linear equation here, and the new lines have to go through this point. So the first thing I do is I find the slope of the original line. By the way, there's a sneeze coming. Sorry about that. All right, so the slope is going to be 2/3, right? So now I'm ready to do the parallel line. So the parallel slope is going to be 2/3, right? Now I need the y-intercept. So I'm going to go use slope-intercept form here, and I'm going to do y minus 2, which is going to equal, oh, sorry, I'm going into point slope form. I don't know why. Okay, maybe it'll be easier. All right, 2/3 times quantity of x minus 6. Now, if they don't ask for a specific form, you're done, because I just gave a linear equation parallel to the original equation that goes through the 0.62. I did it in point slope form. If they ask for it in slope intercept form, well, then it's just a matter of getting y alone. So first I'll distribute, right? And so I'll have y minus 2. That'll equal 2/3 x minus, and 2/3 of 6 should be 4, right? Or in this case, -4. 3 will go into there twice. 2 times -2, -4. All right. And then I'll add 2 to both sides, and I'll get 2/3 x minus 2. And there you go. There's the parallel equation. Now, to get the perpendicular one, it's pretty much the same problem, except my perpendicular slope will be different. My perpendicular slope is going to be -3/2. So I'll go y minus 2. That'll equal -3/2 times a quantity of x minus 6. And again, if they don't ask for it in slope-intercept form, I'm done. I can stop right there. But if they do ask for it in slope-intercept form, I'll do the same thing. I'll distribute, right? And so I'll have y minus 2 equals -3/2 x plus, I think that's going to be plus 9, because 2 is going to go to 6 3 times. Yeah, plus 9. And to get y alone, I'm going to get y equals -3/2 x plus 11. And there you go. The red equation is parallel to the original equation, and it passes through 6-2. The blue one is perpendicular to the original equation, and it also passes through 6-2. Okay. One more thing from Chapter 5 I want to mention, lines of best fit. Now remember, a trend line, or a line of best fit, you want to follow the path of the points. You also want to divide them as evenly as possible. Okay? So let's see here. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like there's 8. So what would happen if I did this? So, and you want to try to have as many points above and below the line as possible. So let's see here. If I did that, I would have 3 above and 3 below, and the distances are pretty minimal. Okay, now, to actually write the equation of this line, I would need to find the slope, and it looks like I'm going through 2 points. You know, this point here, right? And this point here. And in that case, I would use the formula y sub 2 minus y sub 1. Oops, that's not, doesn't look like a 1, does it? That's a little better. Okay, over x sub 2 minus x sub 1. And that would give me the equation of the line. All right, now, I know my slope will have to be negative. And then once I know the slope, I could use one of the points. I could find out the y-intercept of the line. Okay? Now, I've got 2 different graphs here. If I have something like this, come on down real quick. My line would be going up to the right, and this would have a positive correlation, though it wouldn't be very strong. Okay, I'll be up in bed in a second, buddy. Okay. All right. The previous one would have had a negative correlation, and what the negative correlation means is that as x is increasing, y is decreasing, right? Yeah, as the input is going up, y is going down. And this one, as x is increasing, so is y, right? Okay, now this one here, this big glob, this is intended to be another problem. This one here would be impossible to draw a trend line because as x increases, sometimes y stays the same, sometimes y increases, and sometimes y decreases, right? It's kind of globular. So this one here, we would say there's no correlation, and we wouldn't really be able to draw a line of best fit. All right, well, as you can hear, it's bedtime at the Lawrence household. So I am going to say goodnight on this video, and I will make ones for Chapter 6 and 7 and 8 and 9, etc. All right, I'll be posting them in the next couple of days. So this is your first video. If you have more questions about this, you're welcome to ask in class. You're also welcome to come in after school and, of course, check out the study plans on Math Excel. All right, Mr. Lawrence signing off. Have a good night, everybody.